Thanks for the invite. It's always nice to come to Bristol. So I'm Sam Thompson. I'm a Professor of Health Informatics, and I've got lots of job titles. I used to be the IT guy, and now I'm accidentally the head of department. I'm not sure how that happened, but it happened, and that's life. I've stolen some slides from a friend of mine, so I'm crediting him here. That's him there. If you go to Nottingham, go find Anwar and say hello to him. He's an IT guy, so he won't want to speak to you, but speak to him anyway. So I want to talk about trusted research environments, starting with those. So we run a lot of trusted research environments. We run a lot in the UK, but we also run it for the government of Canada and for the government of Australia, which obviously makes some interesting time challenges, but gives us a really worldwide perspective on how it's all the same but different. In the UK, we run, these are some of the ones that we run. Our relationship with Bristol is very strong. We support the UK LLC, which is run out of Bristol, and we also support the ALSPAC study, but we support many other trusted research environments. Our definition of trusted research environment is different to others, as is where it's many projects, many data sets, and many people. Some people's definitions are one project, some data, and a few folk. That's not a problem, but ours is these are bigger installs. So the scale of trusted research environments that we run, this was updated yesterday. So we have 1,621 people connected yesterday. That's how many people kind of coming in. And this is a graph of the active users. They're not all born equal, but some of them are specialist trusted research environments, and others are generalizable, like the SAIL data bank is about the whole population of Wales, Dementia Platform is about dementia of the UK, and so on and so forth. So we're running, it's hard to count a TRE, but we're running 21 plus 8, or 29 if you're good at maths, 29 TREs in the UK at the moment, and we're about to sign a contract to run the island of Ireland as well. So what do we mean? The 5 SAFE framework, which again was invented in Bristol, so there's a lot of heritage here. It's about safe people, it's about the right people with the right skills coming in into the right setting, which is secure and appropriately secured, to do safe projects, which means that a project is in public benefit. Again, safe data, which means the data is shaped correctly, and we check the outputs going forwards. But loads of people think a trusted research environment is about IT. It's not, it's 110% about information governance. I'm the IT guy, and I spend my entire life worrying about information governance. So it's kind of like, it is what frames everything. So if something is bureaucracy or annoying, it's always because we're fulfilling an information governance requirement, which is always about protecting the privacy of the individuals. Trusted research environments have got extremely popular. Ben Goldacre report came out a few years ago, and since then there was a shift change and everybody's moved to a trusted research environment. And more recently, Kathy Sedlow's report came out, basically reinforcing that. So the future is going to be really, really beautiful. There's going to be AI everywhere. There's going to be data everywhere. You're going to have the best time of your lives. However, right now, it's not quite like that. Right now, everybody's building a TRE, and it's a bit chaotic out there, if I be really honest. But that's evolution for you. Eventually, everybody will settle on workable models, workable solutions, workable things. However, there's the religious wars already. So, you know, an SD is better than a TRE. Everyone knows that, even though TRE is about for years and years and years. This is a distraction. At the end of the day, we're all trying to do the same thing, and we really should get on the same page. There are a number of initiatives. So the SATRA specification and EOSC and Trust, the European thing, is trying to define what it is, what it means to be a TRE, and what is the minimum get out of bed to be a TRE. And I think that's really helpful. Just skip that one. Let's talk about federated analysis. And particularly, so we co-wrote a report. It's 120 pages of completely undigestible content. It's an academic publication. It's really beautiful. And if you have trouble sleeping, this is a fantastic document for you. It's not for everybody. And I think what we're trying to do is kind of disseminate that in a more digestible manner. I think it's also, when I talk today, I'm talking about a specific lens, because not all data is born equal. I'm really talking about sensitive data, data that has a disclosure risk or has potential harm to life. We have a couple of data sets in SAIL where if they were released, there would be a credible risk to actual life. This is a very serious burden on us to make sure that we can protect privacy. So I'm not saying that open data is not important. Of course it is, but it doesn't actually have all of the same constraints that sensitive data has. It doesn't actually have all of the problems that sensitive data has. So what do we mean by federation? Well, I guess it is about joining and making available data from more than one trusted research environments, while still obeying the 5 safes framework, or the principles of the 5 safes framework. So why are we bothering with this? Well, in many ways, sometimes it's easier. So the one on the left, you can go to 2 TREs, combine the data, do your science, come up with some answers, combine your answers, move on. It's not a problem. It's just inconvenient to have to go to more than one trusted research environment. And there is a lot of bureaucracy, and there is difference between them, but it's not the end of the world. But Federation will allow you to kind of have that single lens across them, so it's just easier. But that's not a reason particularly for doing it. The real reason for doing it is actually increasingly, because everybody is building a trusted research environment, data is becoming more and more siloed than it ever has. Because if you're a data provider and I've given you all the spiel about why I'm the best TRE, and we've got a relationship now and you trust me, you're not going to put your data somewhere else because you've sold on the fact that I will look after your data the best. But if someone else has done the same to another data provider, then we're kind of in an impasse of like one data's in one TRE and one's in another. And if you want to combine them, this is going to be a problem. Now, we do ship data sets between TREs, but this is becoming less frequent as the TREs are becoming more rigid. So I used to dine out of this when most of you, or half of you perhaps, were still in school. It's kind of, what TREs are castles, really. And there's a lot of castles in Wales where we come from. And we let everyone in, but they're massive walls and there's loads of procedures. And in Federation, we're asking you to put a hole in the side of your castle. That sort of defeats the whole point of having a castle, in all fairness. So we are sort of trying to frame it in the UK to kind of get to understand how do we describe this. And it's sort of coming down to 2 things of data pooling or doing federated analysis or federated learning. So data pooling is easy, it's just about moving data. So we can move data either dynamically, permanently, temporarily, etc., etc. This is not really that hard, but it's a model. The other one is where we allow you to touch the data, leave it in situ, but touch it in real time. I query all these databases simultaneously from a trusted research environment. And the other one is where you can pick up a job and submit it into the TRE, it runs, and the answers come out. We'll go into more detail about these now because there's a sort of difference. So DARE UK funded a phase 1 where Swansea built Teleport, and in collaboration with Nottingham and Manchester, we built Trifix, TRE-FX, and they cover these sort of use cases. Nobody addressed federated learning at that moment, but phase 2 has just been funded, and we are going forwards to address federated learning, which again, I'll talk about in a minute. So let's talk about these 2 products that we have they are real, they're open source, and they have been deployed by us in production already. So DARE Teleport is about eyes on, so I'm using that word. And what the proof of concept project was, we're running Wales, we connected to our equivalent in Scotland. The SERP also runs Northern Ireland, so it was a bit easy, but we connected Northern Ireland in as well. But this was all about trying to get a scale of people. So, 5.4 million plus 3.3 million, etc., got that scale of data. And it was fundamentally about, IT, sysadmin, infrastructure, planning at the end of the day. But the thing that we did establish was that we were going to do this by popping up a TRE inside a TRE, a common space where all the other TREs had the command and control of this pop-up TRE. Because in many ways, information governance, or proportion of information governance, is about maintaining command and control, maintaining visibility, having a say in everything that happens to the data, including the egress and the users that get added to it. So if we popped up a TRE in Scotland and connected the pipes and so on and so forth, but our local information governance folk and administrative staff can still control that remote site, it's kind of an extension of your TRE rather than you giving the data out. So if you were to let someone in a pop-up TRE, all the participated TREs have to agree, and if they all agree, like 3 keys, you then come in. And when the data comes out or egressed, it has to be approved by all of the TREs, and then it comes out. So whoever put bureaucracy on the Slido a minute ago, this is a classic example of super bureaucracy, because it's kind of like everyone's bureaucracy. But it was a way of kind of establishing federation with eyes on all the data, while not really fundamentally changing the operating model of the TRE today. So, of course, the end user experience is the best end user experience, because you get a database, Trino in this instance. When you look at the tables, they all look like they're next to each other, and you can join them together, and you can do whatever you want to do, whatever it means to do data science. And then when you've got your answer, you take a single answer out. Yes, okay, the process is 3 stages, 4 stages, but it's only one process as far as you're concerned. So it's kind of business as usual in many ways. So the model is we kind of have a pop-up space, and the arrows go into the TRE, and then we touch the data in some meaningful way. Datalytics is the opposite, it's eyes off. So this is the other end of the spectrum. And the arrows are going the other way, which is the key thing here, where actually you submit a job at another TRE, it gets picked up by the other TREs, brought down, runs, and the answers get egressed and then go back. So the answers get egressed at the point of the TREs. Not the other one is the answers get combined together, then egressed. This is they get egressed separately, and by the time the data's come back, it's been egressed, it can be released. So it doesn't really matter where that submission layer is. In reality, it's all about standards. So we chose Global Alliance for Global Health Task Execution Service as the specification for what it means to do a job. And we come into one of these submission layers, they get queued up, they get run. But this gives us the advantage of running on HPC or virtual machines or scalable Kubernetes clusters. So there's lots of options down here about what it means to run your job, which means that you're doing routine data in EHR data on a database, or you're doing medical imaging or genomics. It doesn't really make any difference to us because it's just about the right number of servers underneath at the execution point. Specification itself is relatively easy. Not as easy as SQL, I'll give you that. You specify the files you want to bring in, the files you want out once you've done your analysis, how much compute you want, and what are the steps that you want to run at the end of the day. This is a well-established, been around for many, many years. What we've done, though, is things like RO crates, which is a reproducibility construct, where it packages the data, the answers, and the analysis together. You may be familiar with it. We bolted that on top, so if you want to use RO crates, it all looks like RO crates, but behind the scenes, it's all getting transferred to this sort of technology. We've gone live where there's a facade gone on top. It looks like a SQL engine. And when you issue SQL, all it's really doing is packaging up the SQL, put it in a job, submitting it, and off you go. Because I think at the top, we do need to kind of hide some of the complexity of this. Not everybody wants to build Docker containers. Not everybody wants to write YAML. I don't know why. So eyes off is really hard because eyes on is what you've got today. At least, no matter how much palaver you had to get the data, you get to see it. You get to see the top 10 rows, like that's somehow reassuring, and you can now do data science. But if you can never see the data, this is going to be really difficult, actually. So we kind of think that synthetic data is going to be really important in this space. If we gave you synthetic version of the data sets and you can have eyes on them and you can work out your analysis, work out whether your algorithm is even going to run, see for missing data, and so on and so forth, you could then build an analysis that would work, and then you switch to eyes off data. We kind of think unless we do this, it's kind of going to be too much of an impediment for the data science community. People like OpenSafely is very similar to Trifix, but they did it from day one. What they did is create some synthetic data so that you build on your laptop with synthetic data, so you know what you're doing, then you submit against the real data. This was a very sensible decision. But of course, there's a secondary win, that if we create synthetic data for every data set in every TRE, that's a great training opportunity because effectively that's about not removing governance, but certainly lowering governance to kind of allow that access to it. If we compare the two products to each other, or two approaches to each other, you send a query in or you send a payload in, you can see all the data, but you can only see the metadata. The key thing was the governance was normal from a TRE's perspective, right? At Trifix, the payload comes in, it runs under your user context. It's no different to you logging into a remote desktop and running the same analysis from a TRE governance perspective. So the two products were deliberately built for this because Sale Data Bank has got one of the more conservative governance models deliberately because it's got such a big collection of data. But there's a big difference at the other end about whether or not you kind of egress all the results and that you get safe results, then combine them, or you can combine anything to kind of continue to process it down, ready for an answer to be egressed out. I think egress is like the fundamental thing about a TRE that not a lot of people understand. It's the point when the TRE loses control. It's the point when the jurisdiction, control, and the responsibility of the TRE stops because it's gone out. If I release data to you, then you could put it on the side of a bus. It's your choice. It's not my responsibility anymore. We do release data under license. There are ways of doing it, but we don't want to do that. We only do that if there's a huge public benefit. We don't really want to do that We want to do what we said on the tin, and that's protect the identity of the individuals. Talk about federated learning then. So the second phase of the Dare 2 is funding a number of things. I'm not going to the whole program, but we are creating this thing called Director, a product, and its job in life will be to connect all of the TREs together and dynamically install all of the moving parts needed to support federation. And it's going to create data planes, multiple data planes between the TREs, and on those data planes, it will install the software that you want to run in order to do your analysis. Director has not been opinionated about what that software is, because we know that this is a very emerging market. The kind of software that you might have used today will be different to what you want tomorrow. So we're not trying to make a product that is tied in. So this is mainly a plumbing infrastructure project, but it's obeying cybersecurity and respecting information governance and all of those sort of procedures and paperwork stuff is all going to be dealt with. The legal contract of TREs being joined together will be dealt with by the Director project or program. But at the end of the day, we're going to support these projects initially. And as you can see on there, Vantage 6, OpenFL, Flower AI, they're all federated learning products. So they're very much in there, as well as the more traditional hub and spoke analyst type projects. And I think someone spoke to me before. You had a talk the other day from the Fridge guys. The Fridge guys are there to kind of plug in the HPC. So the thing about federated learning is it needs an aggregator. It's not, you need somewhere to pass the coefficients back and forth or the model back and forth. So where is that aggregator? Because if that aggregator is not you're going over your border. And as I reiterated a minute ago, that egress point, that border control is the real thing that TREs care about. And yet things are flying over and back and over and back. TREs hate federated learning. We've done 5 federated learning projects. Every one of them has been an absolute nightmare, a real drama from an information governance perspective. And it's kind of been really difficult because it requires you to trust somebody else who you know nothing about, and yet all of the legal context. I'm the one that goes to jail if the data gets released. So why would I risk my career, my family, my children's education because somebody did the wrong thing over there? Very difficult, but we do need to find a way of making it work because it is a really important tool in the arsenal of the data science community. So how do we, so the other thing that we get is when people want to do federated learning, they go, oh, it's federated learning, that's fantastic, I'm really excited for you. What sort? Well, I don't really know, I have to see the data. Well, that's going to be hard to fill in the forms then, isn't it? You know, is that the information governance review panel goes, they don't know? No, they don't know. Everyone knows. No, they don't know. And that's because they actually don't know, because there's many ways of doing the AI or the algorithm and so on and so forth. Genuinely, they don't know. They've got all the enthusiasm in the world, but they don't know. And that's fine, actually. So we need to kind of create the ability for them to kind of have the data, see the data, kind of build that up in a safe way, and then switch to, and then actually fill in the form. Because once people have started a federated learning project, a little bit into it, they kind of know what they're doing. They could, if they were filling the form again, they'd know exactly how to describe it. But it's this data that goes past. If it's just coefficients, there's no problem. If it's AI models, it depends whether the AI model's got the data in or not. And it's a whole can of worms in this one, you know. And I think the other problem is that the non-data science folk who run the TREs don't really understand this AI model. What does that even mean? I mean, the word AI is just something you put on every funding application. I'm glad you're the AI university, because it's kind of like no one really knows. It's not even a real term, right? You know, it's kind of, you have to get more specific about what you even mean by AI, right? So there's a real bit of a problem here. And of course, in reality, it's worse than that, isn't it? Because you've got the centralized aggregator model for federated learning, and as it gets too big, you actually have to go to hierarchy where you kind of like subsets do it and then combine it together. This is the only way they're really scaling. And then there's the swarm learning and ring network. These are absolute nightmare from a TRE's perspective. Like, they might be cool, but by default, I'm hoping you don't get funded or go away, because this is going to be an absolute nightmare to make it up. Because this, at least you can describe where the data is. It's in that aggregator or in the sub-aggregators. This is the data that you have no idea whether it's safe or not, is at every endpoint, flying around all the time. But your border, your responsibility is around your one box. And yet you have to trust absolutely everybody. And anybody on there gets breached, you all get breached. But think about it from the cybersecurity perspective, this is more difficult, right? And Ring's no different, it's just less lines. And then, of course, there is, so I've stolen these slides, there's horizontal data and vertical data. I don't like these, I think they're the wrong way around, but too late, the world's gone like this. So, horizontal is where the data set in one TRE is everything known about the set of people, and the other TRE is the same data about a different set of people. Everyone's doing federated learning in this space. But sometimes, so half of the data is known about someone in one TRE and half in the other. I haven't seen any evidence, I'm not saying there isn't there, but I've seen no evidence of anybody tackling this issue. Because that means that actually, how do you do that, right? And of course, the real world is it's never that simple, is it? There's always a bit of a crossover. So there are approaches. Homomorphic encryption is one of those. It's basically encrypting the data in a predefined way so that you can kind of know that actually when the data goes across that border, it's sort of protected. It doesn't remove the need to still trust the aggregator, though. It's another level of protection. And these are not my slides, and I don't even pretend to understand it, but you can kind of tell by the language here, it's got complicated. But it's kind of like, it means you can't do all types of science. You have to do, whatever you encrypt to the two sides of TREs has to be the same as if you encrypted the two before you put it together. So not every type of science can be done using homomorphic encryption. And this tells me everything I ever wanted to know about life. Damn, that's complicated. It hammers the CPU. When you do this, if your data gets big, it almost becomes undoable because the computational burden gets huge exponentially as the data gets bigger. So it's not always the answer, but we have used this successfully, or data science have used this successfully on two projects that we've done. This is how it works. You can have the slides later, no one really cares. So homomorphic encryption is a possible answer, and we are doing a big project with America on medical images right now, where they're going to use homomorphic encryption. We're still really nervous because they still can't yet describe exactly the sort of the way they're going to encrypt it, because actually it still depends. So we're still back in that whole. The other way is perhaps if we got back to that synthetic data idea. What if we had synthetic versions of every data set? And we let you do this, where you discover what it means to do your science, and the data can go back and forth. And I still treat it like it's sensitive, but I'm less concerned. You could probably get to the point where you could actually describe what it is, what it means for you to do federated learning really, and then we could have a much better judgment about the risk of you doing it that way or this way or whatever. Synthetic data we're not going to talk about today, but there are frameworks where even this is a trade-off, because privacy versus utility versus fidelity, they're all sliding scales. So I might have loads of privacy, but it's no use to you, loads of use to you, but actually there's no privacy. So even this is going to require a little bit of balance, discussion, and risk appetite to kind of get the synthetic data in that nice balance so that it's got enough utility for you to kind of do the proof of concept science, and reducing the risk as privacy to as much as possible. The other one that we have also deployed is to kind of steal the idea of teleport. What if we let the aggregator be in one of these pop-up TREs now, and we secure the comms between it? And that's another thing. If you look at a lot of the federated infrastructure like Flower and stuff, the security of that communications is very poor from a pure networking point of view, right? So we are talking about putting additional mesh overlay networks and VPNs and all this zero trust networking between the endpoints, even if you come along and say, oh, use Flower AI. So we can do that. And if therefore, I can kind of I don't have to worry now. The scientists can just use the the federated learning. I don't really care what the data goes back, because it's into a trusted space that we all trust. And that's the key. We all trust, right? So I think the future is going to be quite exciting. We are funded in the next 12 months to get the plumbing sorted, with a rollout in the next 12 months after that. Otherwise, we don't get paid. But I think we also are working on what's the next level of governance, because in Triffic and Teleport, I cheated. I knew what information governance was, so I built a product that matched the information governance model. I haven't really been pushing the boundary about in the IG model. I think as we go forwards, we've got a project in sale at the moment called Safer, which is looking at how do we tweak, not throw away, how do we tweak the information governance model for a slightly different future where we know that we're always partnering with someone else who has a different information governance model. How do you find commonality between it? How do you get that common set? You know, how do you know if you can trust another TRE? How do you know you can work with someone? These are questions we haven't asked before, because in the TRE land, it's just been an arms race. I'm not working with a TRE, I'm trying to take them out. It's different now, I have to work with them. How do you have that trust? Right? But of course, the ultimate game here is for people like me, the infrastructure sort of people, to make a lot of these problems go away, so that you, the data scientists, or the clever people, can come up and do your science. And I think that's our job in life. So, Giacomo, thank you for your invite.